Hello everyone, welcome once again to Learn Mathematics. This is your maths teacher Rekha Chhabra. I hope you all are doing great students. So please don't forget to like, share and subscribe this channel and keep learning mathematics through my YouTube videos. So today's video is based on three-dimensional geometry, which is chapter number 11 as per NCERT. Here we can see how basically a 3D plane looks like. We very well know about 2D plane, right? Two dimensions, x and y. Now we have one more axis which is called as z-axis. We have already done a little bit of 3D in class 11 where we studied about octants and coordinates. Now let's move forward and understand few more things like position vector, and then we will discuss straight line in a space, and then we'll see few examples. So let's start. Coordinates of a point in a space. Let O be any origin, right? And OX, OY, OZ be three mutually perpendicular lines taken as x-axis, y-axis and z-axis in such a way that they form a right-handed system. The plane YOZ, ZOX and XOY are respectively known as YZ, ZX and XY plane. And these planes basically divide the space into 8 parts called octants. This much we have done in class 11th. Now look at these vectors I cap, j cap and k cap. These three vectors are called as unit vectors in the direction of x, y and z axis respectively, or we call them as direction vectors also. Position vector of a point in space. Position vector which tells us the position of a point, right? If we have a point in the plane, let's say this is our 3D plane x, y and z. Now we have any point P whose coordinates are, let's say A, B, C or x1, y1, z1, right? So if I join this P with origin O, so this vector OP will be written like this. Position vector A I cap plus B j cap plus C k cap. Basically, position vector is a vector whose initial point is at origin, which starts from origin. Now here we have some basic formulae that we have already done, some results on points in space. If we have 2 points, we know how to find distance. Distance between 2 points, PQ will be equal to simple distance formula. We have used this formula in class 10 for 2 points, right? Now we have 3D plane, so we have to add this Z2 minus Z1 also. Then we have section formula, right? Then we have midpoint formula and centroid. I don't think anything is new for you students. You have already done it and we have used all these formulae so many times. Then we have some results on lines in space. Direction cosines, first of all, as we have done in vector algebra also. Direction cosines are what? Direction cosines are normally cos alpha, cos beta, cos gamma, and we represent these direction cosines with the letters L, M and N. And we have one important result, that is L square plus M square plus N square is equal to 1. DCs of x-axis are 1, 0, 0 because we are talking about x-axis, so y and z are going to be 0. DCs of y-axis are 0, 1, 0. DCs of z-axis are 0, 0, 1. Direction ratios of a line. Any three numbers A, B, C proportional to direction cosines L, M, N respectively of a line are called the DRs. So L by A is equal to M by B is equal to N by C. And if A, B, C are the direction ratios of a line, then its direction cosines can be calculated by using these three formulae. If R is equal to this, then the direction ratios of R are A, B and C. If any vector is written in the component form, let's say for example, if I have any vector R written as 2i minus 3j plus 4k, and if I ask you what are the direction ratios, so you can simply say DRs are 2, minus 3 and 4. Its scalar components are called as A, B, C. Let PQ be a line joining these 2 points, then the DRs are x2 minus x1, y2 minus y1 and z2 minus z1. Now let's talk about straight line in space. Equation of a line passing through a given point and parallel to a given vector. We have to study two cases. First case is this, and another case is equation of a line passing through two given points. Right? So the vector equation of a straight line passing through a given point with the position vector r1. Right? There is a point and there is a parallel vector and parallel to a given vector m. Okay, so the equation will be r is equal to r1 plus lambda times m. Clear? Or simply we can say r will be equal to a plus lambda times b. If we get confused in r and r1, so we can simply write down as r vector will be equal to a plus lambda b, where let's see there is a line which is passing through this point. Let's call it as p. Okay, and the position vector of this p is a. Now this is parallel to a vector b. Okay, and now let's take any random point q, fine, and this is vector r. So now the equation, or we can say vector r, will be equal to a plus lambda times b. This is vector form. This is vector form. Now if we have to talk about Cartesian form, so what are we going to do? We are going to talk about x-axis, y-axis, z-axis. We will talk about coordinates now, right? And it will be x minus x1, y minus y1 and z minus z1 upon their drs, a, b and c. Drs of the vector which is parallel to that line, a, b and c, and x1, y1, z1 are the coordinates of that point through which the line is passing through. The equation of a line having direction cosines L, M and N and passing through x1, y1, z1. If in case you don't have A, B and C and you are given DCs in the question, right? So there is no problem. You can write the equation of the line like this. Instead of A, B, C, we will write down L, M and N. Now equation of a line passing through two given points. Right, so let's talk about vector form first of all. Vector form will be r is equal to r1 plus lambda times r2 minus r1. What is r1 and r2? R1 and r2 are those 2 points. Let's say this is p, this is r1, position vector is r1. Let's say this is q, position vector is r2, right? So the equation will be this. And if I talk about Cartesian form, so it will be x minus x1 as we were doing in the last case upon x2 minus x1. And now what is x2 minus x1? x2 minus x1 is simply the dr, right? Y minus y1 upon dr and z minus z1 upon dr means a, b and c. These are basically a, b, c of a line, drs of the line. So that's how we are going to do. Now, look at this example. Find the vector equation of a line which is parallel to this vector. Parallel to this vector means this vector is going to give us what? A, B and C, right? So we know A is 2, B is minus 1 and C is 3, and which passes through this point. So what is this? This is x1, 5, y1 minus 2 and z1 4. Also find its Cartesian equation. Now we have to find vector and Cartesian equation both, right? So what is vector form first of all? Vector form is a plus lambda b, right? R is equal to a plus lambda times b. So what is a vector? A vector is the position vector of that point which is given, right? So what is given? This line is passing through this point. So it means what? 5i minus 2j plus 4k plus lambda times b. B vector, what B vector does? It basically gives us direction which is parallel to the given line. So find the vector equation of a line which is parallel to this. So this is vector B. So it means 2i minus j plus 3k, right? And Cartesian form, how are we going to write? X minus x1 upon A, y minus y1 upon B, and z minus z1 upon C. So x minus x1, what is x1? x1 is 5. X minus 5 upon 2, y minus y1, it means plus 2 upon minus 1, and z minus z1 means 4 upon c. C is what? 3. That's it. Done. Next example, the Cartesian equation of the line are these, right? 3x minus 3, 2y plus 1 is equal to 5 minus 6z. Write these equations in standard form. First of all, we have to write in standard form. What is standard form? Standard form is x minus x1 upon a, like that. And find the drs of the given line, and then we have to write it in the vector form also. Okay, so first of all, let's talk about standard form. So the given equation is, given equations 3x minus 3 is equal to 2y plus 1 is equal to 5 minus 6z, right? This equation is not in the standard form. So how are we going to write it? We are going to write in the standard form. What we have to do? We have to divide it by 3. So let's divide. It will be x minus 1 upon 1 by 3, right? And here what can we do? We can divide by 2, y plus 1 by 2 upon 1 by 2, and here it should be 5 minus 6z, so we can write down as minus 6z plus 5, right? And minus 6z plus 5. Okay, and now we have to divide it by minus 6, so it will be upon minus 1 by 6, right? So what it is going to be? X minus 1 upon 1 by 3 is equal to y plus 1 by 2 upon 1 by 2, and it is minus z plus z minus 5 by 6 upon minus 1 by 6. So this is the standard form, right? And what are the drs now? Drs, this is standard form. And now drs, what are the drs? 1 by 3, 1 by 2, and minus 1 by 6. Now we have to write it in the vector form also. So vector form is what? R is equal to A plus lambda B. A is what? A is the point, right, on the line. So means this, x minus x1, y minus y1, and z minus z1, right? So x minus x1. What is x1? 1 only. So 1i, y minus y1. So it means minus 1 by 2 j, and z minus z1 means plus 5 by 6 k, plus lambda vector b. Vector b is what? Direction vector. So it is 1 by 3i plus 1 by 2j minus 1 by 6k. Now you can simplify it, and that will be the answer. Now, when the coordinates of 3 points are given, the condition for 3 given points to be collinear is this: x3 minus x1 upon same dr, x2 minus x1, y3 minus y1 upon y2 minus y1, z3 minus z1 upon z2 minus z1. Very simple. Then let's talk about shortest distance between two lines. Coplanar lines. Coplanar lines means two lines lying in the same plane, right? Coplanar lines are either parallel or intersecting, right? Now skew lines, very important, skew lines. Two lines in the space which are not coplanar are called skew lines, and skew lines are neither parallel nor intersecting, like this. If we have a line in this plane and we have another line in this plane. So definitely they are neither parallel nor intersecting. So line of shortest distance between two skew lines. If we have to find the distance between two skew lines, shortest distance. So see what is the formula? In vector form, this is a formula we have to find. Let's say this is first line and this is second line. These are the standard forms. So the shortest distance will be A2 minus A1, A2 minus A1 and dot B1 cross B2, their cross product upon its magnitude of this cross product. So that's how we are going to find the shortest distance. Now, condition for two given points to intersect. Suppose that the two lines intersect, then definitely the shortest distance between them will be 0. Now, we will discuss the example based on these. Distance between parallel lines. If we have to find the distance between parallel lines, so this is the formula. Vector B into, not into, we call it as cross product, right? A2 minus A1 upon magnitude of B. Shortest distance between two skew lines in the Cartesian form is this. And condition for two given points to intersect. What is the condition? If L1 and L2 intersect, then definitely shortest distance will be 0. And if L1 and L2 do not intersect, then what are they? These lines are definitely skew lines. Now look at this example. Find the shortest distance between the lines whose vector equations are these two. Okay, these two vector equations are given and we have to find the shortest distance. First of all, let's compare the given equations with standard form. R is equal to A1 plus lambda B1. R is equal to A2 plus lambda B2. And let's find the values of A1, A2, B1, B2. Right, what all we need? We need A2 minus A1 first of all. So let's do minus 4 minus 4I A2 minus A1, right? We'll calculate minus 10I minus 2J, right? And minus 3K. After that, we need cross product of B1 and B2. We will calculate it. Now put the values in this formula. We need magnitude as well, that is 12. Put all the values in this formula and get the shortest distance. That's how we are going to use the formula. Next question, show that the lines intersect and find their point of intersection. First of all, compare the given equations, find the values of A1, A2, B1, B2, right? What we need? Same as last question, we need first of all A2 minus A1, we'll calculate. Then we need cross product of B1 and B2, we'll calculate. Then magnitude 94. Put all the values in this formula and we have seen that standard shortest distance is 0. We have seen the shortest distance is 0. So it means definitely the lines intersect, right? When the shortest distance is coming at some point, it is 0, then definitely two lines intersect. And if two lines intersect, then definitely there will be a common solution. So thus for some particular values of lambda and mu, this is going to be true, right? And now compare and get the values of lambda and mu. So the position vector of the point of intersection of the given line is R is equal to I plus j minus k cap plus 3I minus j. Putting the values of lambda and mu. Lambda is what? Lambda is 1. So R vector is equal to 4I minus k. And the point of intersection is definitely 4, 0 and minus 1. So hopefully you must have understood these concepts, and a lot of questions we have discussed and we are discussing in our online session. So students, please don't forget to join the online classes. Thank you very much.